Hi guys, today we will learn to work with another statistical tool which is present in ArcMap and which can be helpful. It's called multi-distance spatial cluster analysis, which is also known as Ripleys function. This tool, also known as Ripleys K function, examines the counts of neighbor features at several distances. So if the count is higher than what would occur in a random distribution, the features are considered as clustered. A graph is automatically created for the tested distance. So using the Ripley's K function for pattern analysis measures the distance between features to determine clustering. But unlike the average nearest neighbor index, it includes all the neighboring features in the calculation, not just the nearest one. When plotted on the graph, the area with the greatest distance, the two values, is the point of most significant clustering. So we again have this battalion area with calls for service, and we want to know whether they are clustered or not. So we know that it's clustered actually from the previous exercise, but this tool will take into account the relationships of each feature to all other features. So the peak at which the observed k-index exceeds the confidence envelope, the most is the point at which the greatest clustering occurs. Let's open this multi-distance spatial cluster analysis. Let's choose this calls for service. So it will generate a table. So let's say table 1. So permutations, weight field, beginning distance, so battalion 2. So study area method we will choose here, boundary none, distance increment 200, 100. So first we will create for 0 permutations. Let's see what we will get. So it will generate both the table and such kind of window. So this is observed, this is expected. So see, there are some randomness here. So if we will open the multi-distance, this tool, there is some brief description we can compare. So see that this is a cluster pattern. So this is expected random spatial. This is observed. So this lower confidence envelope and high confidence we cannot see here because they don't match. So it determines whether features or the values associated with features exhibit statistically significant clustering or dispersion over a range of distances. Let's add to the layout. So again we will generate this multi-distance spatial analysis, table 2. So now we will take this 99 permutation. So 99 permutation sets of 99 sets of points values are randomly placed. So again, value field, weight field is FEE. Beginning distance again 200, and increment is 100. So battalion 2. Let's click OK. So it will take time for this modeling of permutations. So go to table 2. So see that there are two more attributes here. We can go to results and see this message. You can close here. So these are the messages for relating to this tool, observed, etc. So we can go to graph here, create a graph, and there is, let's say that choose vertical and field expected. Here a y field, x field is observed. Or we can choose difference k, so different k. See that difference k observed. So we can also add create a difference here. So let's create a difference, calculate the difference between the observed and high confidence interval. Let's see what we will get. So this is the difference between the observed one and high confidence envelope. We can go again to create a graph, vertical graph. So this is a, let's say, choose the difference. So see that the difference for object ID. So we can click here, observed. Difference between observed and modeled. So see the biggest one is here. We can choose here also expected. So the biggest in 400 and 900. So we can click next and finish, and it will create such kind of graph, and we can add it to the layout using right click of a button. So this tool is can be very helpful. So Ripleys key function can be used to examine the clustering of a certain plant species. A regional search may be done for the significance of clustering rather than using only the next nearest neighbor. A catalog sales company may look for clustering of customers, but on a more regional level. This clustering will take into account all the customers across a broader distance and reveal more subtle patterns. So we can also manipulate with this tool using high permutations and compare the results. Also, it's better to read some information about this tool and statistical analysis, Ripleys key function, because even for me it's still certain things are unclear, so better to be equipped with theory before using this tool.